So welcome back to video 2 for lesson 5.5, average value of a function. Now I've included an extra example because this one includes substitution in your solving. And a lot of the homework questions do have substitution in them, but none of the example questions did. So this is just an extra example. So they want us to find the average value of the function f of x equals x divided by x squared plus 1 cubed from 1 to 3. So I'm going to start off by employing the average value function that I have. f(a)(v)(e) equals 1 over b minus a times the integral from a to b of the function with respect to x. Okay, so this becomes 1/2 times the integral from 1 to 3 of this. Okay, now I need to pick a value for my u because I'm going to do substitution for this. So I notice the inside function is this x squared plus 1. So u equals x squared plus 1. And du equals 2x dx. Now, looking at this, I see a dx is here, so I can replace that. I see an x is in the numerator, but this 2 is extra. So what I'm going to do is divide it to get it to the other side here. Okay, so this 2, I'm going to just cross it out, and I'm going to divide by 2 over here. So now this can get replaced. It was the dx and the x right there is going to get replaced. Okay, so my new integral is going to be, again, I have that 1/2 times this 1/2, the integral. Now, this was 1 over my u value cubed. Okay, and this x and dx are going to be replaced with this du and the 1/2 that I put in earlier. Okay. Now I have to fix my boundaries because I don't like going back to this u function. I like to just keep it in terms of u. So what I'm going to do is I'm going to put 1 in to the u function. 1 squared plus 1 is 2. I'm going to put 3 into the u function. 3 squared is 9 plus 1 is 10. So now I can ignore this u function and just finish it off using this. Okay, 1/2 times 1/2 is 1/4. Now this 1 over u cubed is u to the negative 3. So this integral, I'm going to go up by 1 on my power, so it's u to the negative 2. And then I'm going to divide by that power. So it's times negative 1/2. And I'm going to evaluate this from 2 to 10. Okay, so this becomes negative 1/8 times 10 to the negative 2 minus 2 to the negative 2. And I can put this right into a calculator and it comes out to be 0.03. And that's my answer for my average value of this function on that interval. Okay, we have one more example to do. And this one is a bit odd and it pulls up some information from a previous lesson. Okay, but it is our application question. So example 3 from your lesson says, show that the average velocity of a car over a time interval t1 to t2 is the same as the average of its velocities during the trip. So they want us to take the average velocity function in these times and show that it's equal to the average of its velocities. Okay, so I'm going to start out with using the mean value theorem. Now, this is not the same one that we're using in this lesson. In lesson 3.2, we learned how to find the average value of velocities on an interval. And to do that, it's just take the displacement over the change in time. And that was from lesson 3.2. We did that. Okay. Now, displacement is the change in position. So I'm going to take the later position. So remember, the position function is represented with s of t. So position at any given time. So this is s of t2 minus s of t1. Okay, so that's the displacement, the change in position, over the change in time. That's t2 minus t1. Okay, so that is the average of the velocities during this trip. Okay, so now let's use the mean value theorem for integration to find the average velocity on this time interval. So I'm just going to take this and put it into the function that we had in our lesson. So this is the function from 5.5. Okay, we had 1 over b minus a, so t2 minus t1 times the integral from t1 to t2 of my function. Now this is the velocity function, so it's v of t with respect to t. Now I'm going to do the integral. Now remember, the integral of velocity is position. It's the antiderivative of velocity. So this becomes s of t evaluated from t1 to t2. And it's still times this fraction. Now, if I was to actually evaluate this, my s of t becomes s of t2 minus s of t1 times that fraction. Okay. And if I multiply this, I'm going to get this over this. And notice that these two things match. Okay, so my average of velocities during the trip is actually equal to the average velocity of the car on that trip. So that's what they wanted us to do there. Just show that these two expressions are equal. So that's it for this lesson. You're going to have some homework questions posted. So let me know if you have any questions about anything. And I've also posted some other online videos if you want to use those.